There seems to be a little bit of confusion about the calendar for the remainder of the semester, and that's all on me. I'm the one that confused the issue. Originally, in your schedule, if we look at your schedule, I had scheduled exam for Monday, December the 1st. And I thought that was kind of mean of me to do. Although it is what it is. School starts the Monday after Thanksgiving break. I mean, we have to come back to school. But I thought better of it. And I thought, well, I could just put that in the testing center um, so that you could take it anytime between Monday, December the 1st. And I decided to try not to inundate the testing center. So I gave you through Thursday, December the 4th. So the announcement that I send out every Sunday, so the announcement that went out Sunday at midnight, I said that. I said that exam 4, which is over chapter 4, well, exam 5, the chapter 4 exam will be taken in the ACE Testing Center, and you have to take it by Thursday, December the 4th. And that caused some confusion. Also, the instructions for the ACE Testing Center were a bit confusing also. The fact of the matter is, if you've never taken a test in the ACE Testing Center, you have to have a photo ID. You have to bring your own calculator because they're not going to provide you with one. And you have to know my name. And they will have a list of students. Someone's logging into this computer remotely, and it just weirded me out. Anywho, and then they'll put the password in for you, and you take the exam. It's like taking it in here, except it's quieter and nicer over there. So you'll have Monday, December the 1st through Thursday, December the 4th to go over there and take the exam over chapter 4. Now we will meet on December the 1st and December the 3rd. December the 1st, I will look over chapter 4. So we'll look at the chapter 4 exam review. On Wednesday, we will do a review of the final. On Monday, December the 8th, is that right? When is your final? Monday, December the 8th, is that right? Monday, December the 8th at 11 a.m., you will take your final in this classroom. I will not be here. Professor Witt is going to proctor that exam for you. So before I say something that I don't know what I'm talking about, let's go look at the calendar. So let's go to December. So Monday, December the 8th is your final exam. And you will be done after you take the final, you're done, done, done. But as I said, I won't be here. Professor Witt will be here, and she will be proctoring you for that exam. Are there any questions on that? So we are going to finish chapter 4 today. And this is the last of any material that we're going to cover in this course. And we're going to finish up our discussion of quadratic equations. And we're going to get 2 additional methods for solving quadratic equations. It is my experience as an instructor of college algebra for 40 years that you're not particularly keen on solving quadratic equations using the square root property. And I'm not quite sure why, because it's actually a pretty spiffy little quick way of solving quadratic equations. But we are going to go over solving equations using that property. And then every student's favorite method for solving quadratic equations seems to be the quadratic formula. And that's all well and good, except it's a formula, which means you have to plug in numbers into it. And boy, oh boy, do you make sign errors. So it's my least favorite way of solving a quadratic, but sometimes it's the only method you've got at your disposal. And then the last section of this section, we're going to look at what's the strategy for solving quadratic equations. We'll look over some rules that you can use as you move forward. If you have to solve a quadratic equation, you're going to look at it and determine what the best method is. All right, let's start our discussion of the square root property. So I have three quadratic equations here. And what makes an equation a quadratic equation is the x squared, correct? That's what makes this quadratic. If I were to graph this on the coordinate plane, I get that parabola shape, that bowl shape. Okay, so these are all quadratic equations. I maintain that you should be able to look at these and tell me what the solution to each of these is. All right, the first equation says that x squared is equal to 16. 4 is a solution. She is absolutely correct. Why is 4 a solution? Because 4 times 4 is 16. Because 4 squared, 4 times 4, 4 squared is 16. She is absolutely 100% correct. Is there another solution? Yes. What is it? What other number can you square and get 16? What other number can you multiply it times itself and get 16?
16.
You're multiplying two numbers together to get 16.
Mhm.
You're going to multiply it times itself.
Oh,
4 times 4 is 16. What other number can you multiply times itself and get 16? You're making this too hard. Why is -4 a solution to this equation? Because what happens when you multiply -4 times -4? Do you get 16? So the solutions to that equation are plus or minus 4. So what we do is we take this thing and we say, I'm going to take the square root of both sides. The square root of x squared, what do you multiply times itself to get x squared? Is that x? But what do you multiply times itself to get 16? you get 4 or -4. So what we have to do, are you all listening? Are you all awake? Are you paying attention? We have to put a plus or minus in front of the square root of the constant. You seriously need to be paying attention to me, because this is as a matter of fact, just recently watched someone lecture on this, and he said, wouldn't it be nice if they remembered to put the plus or minus in front of it? I said, it would be nice if they would remember to put the plus or minus, because there are two real numbers you can square and get 16. One of them is 4, the other is -4. So this is plus or minus 4. And your text, My Lab Math, will allow you to put plus or minus in front of the 4. This means that x can be 4 or x can be -4. So the solutions are 4 and -4, or you could write that as plus or minus 4. Okay, what's the solution to the next one? 1. What's the other one? -1. There are two numbers you can square and get 1. One of them is the number 1, the other is the number -1. So what's the solution to this? And -6. There are two numbers you can square and get 36. One of those is 6, the other is -6. So this leads us to the square root property on the next slide. If you, and FYI, you're all going to end up in college algebra or functions and modeling or QR, some college level math class. U is the typical variable that everybody uses to represent an algebraic expression. So an algebraic expression is a collection, is a combination of variables and constants using addition, subtraction, multiplication, and division. So if you have U, an algebraic expression, and D is a positive real number, then U squared leads to that U is the square root of D, or U is negative the square root of D. U is plus or minus the square root of D. So if I have x squared equals 25, what's x? 5 or -5, because it's plus or minus the square root of 25. The square root of 25 is, as you just said, 5. So there are two solutions. One is 5 and one is -5. If you're solving a quadratic equation using the square root property, if this is a positive real number, it is not 0. If it's a positive real number, it is not equal to 0, because 0 is not signed. It's not positive or negative. So if that's a positive real number, you get two solutions. I promise. Promise. Always. So if you leave off one solution, you're wrong. You're incorrect. All right. So what's the solution to this? If I want to use the square root property, are we all awake and listening? If I want to use the square root property, I need to get rid of that 3. I need to have x squared. I need to have the algebraic expression squared by itself on the left-hand side. So what do I need to do? Why would I not subtract 3? What are you doing with that 3 in the x squared? You're going to divide it. And why are you going to divide it? They're being multiplied. So to move that 3 over there, since 3 and x squared are right next to each other, that means you're multiplying them. To undo a multiplication, we do a division, correct? So we're going to divide by 3. 3 divided by 3 is 1. 18 divided by 3 is 6. So from the square root property, we take the square root of both sides. Actually, I'm going to write that underneath there. So we take the square root of the left side, but on the right side, we put a plus or minus. Then we put the square root. So you must put the plus or minus, because there are two numbers you can square to get 6. One is the square root of 6, and the other is negative square root of 6. So we get x is plus or minus the square root of 6. Now you can check this. Gosh, I just used my calculator. There's no reason why you have to sit there and square roots. So you go 3, put the square root of 6 inside parentheses, and then use your square button on your calculator and see what you get. Well, you're going to get 18. Then I do the same thing and I put the negative in there, and you're also going to get 18. But you do, when you're squaring something using your calculator, you have to put it inside parentheses. There is a difference for your calculator between this and this. Your calculator sees this and it says, I'm going to square the 2 and then change its sign. When it sees the second one, it knows that I have to take the -2 and multiply it by -2. So the first one multiplies 2 times 2 and then changes its sign. The second one multiplies -2 times -2. So if you're going to square something using your calculator, be sure you put that inside parentheses. All right, let's get a little bit more complicated. Now, again, the square root property says if I have an algebraic expression, u, and that is squared, and that is equal to a positive real number, then I can take the square root of both sides. So u is plus or minus the square root of d. So I can take the x minus 1 squared equal to 5, and I can take the square root of both sides. And when I do that, over on the right, I have to put a plus or minus in front of it. And the square root of 5 is the square root of 5. Now, on the left-hand side, the square root of a square is just whatever that is. It's x minus 1. The square root of something squared, let's put an a, is just a, where a is some algebraic expression. All right, so that's x minus 1 is equal to plus or minus the square root of 5. So what do we do from there? Well, now we're going to have to do a little algebra, a little arithmetic, if you will. So I have x minus 1 is equal to plus or minus the square root of 5. So x minus 1 is either the negative square root of 5 or x minus 1 is positive square root of 5. And then I just add 1 to both sides. Now, on the left, -1 plus 1 is 0. X plus 0 is x. Now, on the right, how in the world do I write that? Well, I've got a square root and a constant, an integer. So I just write them as the sum. Excuse me. So that's just going to be the negative square root of 5 plus 1. And then over here, that's going to be what? Square root of 5 plus 1? And you could also write this as 1 minus the square root of 5 and 1 plus the square root of 5 using the commutative property of addition. It doesn't matter. Same answer. Now, to check this, I would most definitely use my calculator. As a matter of fact, let's go over there and do this. I mean, it's pretty obvious just by looking at it. If I put this in for x, if I put that in for x right there, the 1 minus 1 goes to 0, so it goes away. So you end up with, I don't know that you need a calculator for this. 1 minus 1 is 0, so you end up with the square root of 5 squared is equal to 5. Yes, it is. And if I put this in for x, if I put that in for x, the same thing happens. I have 1 minus the square root of 5 minus 1 squared. Well, 1 minus 1 is 0. So I end up with a negative square root of 5 squared, which is equal to 5. Again, you could square a positive or you can square a negative and get the same result. So the solution is, and I checked this yesterday, my lab math will accept 1 plus the square root of 5 or the square root of 5 plus 1, 1 minus the square root of 5, or it will accept 1 plus or minus the square root of 5. I did check that, and it will accept that as the solution. All right. Quadratic formula. I always have to take a deep breath. So when I first came back to teaching in 2014, I'd been away for 13 years, 14 years. I used to derive the quadratic formula for classes such as you. And can you want to see the look on students' faces when I derive the quadratic formula? So I don't derive it anymore. The quadratic formula is a formula. In science or math, when you have a formula, you have a numerical value for all of those letters. You plug those into the formula and you get a result. So the numbers we're going to plug in are the coefficients on the x squared, the coefficients on the x, the coefficient on the x, and the constant. And what we're going to get out of that is what is x. So we're going to get the two values for x, the solution to that quadratic equation. So the quadratic formula says that x is negative b. B is the coefficient on the x. So b is the coefficient on x. It's that number right there, including whatever sign is in front of it. Plus or minus the square root of b squared. B is the coefficient on the x. Are you all awake and listening to me? Not to be a nudge, but that thing right there underneath the square root symbol will never, ever, 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 ever be a negative number. Ever. Because when you square a real number, the result will be positive. So underneath that square root symbol, that first number is always going to be a positive. All right, enough of that nudging. Then from underneath that square root, from b squared, you're going to subtract a product of 4 times a. A is the coefficient on the x squared term. And you're going to multiply that times c, which is your constant. So you underneath the square root symbol, you're going to take b, you're going to square it. From that, you're going to subtract 4 times a times c. And again, a, b, and c are numbers. These are all numbers, 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 numbers. There are no variables. They are numbers. And then you're going to divide the whole thing by 2 times a. A, again, is the coefficient on the x squared term. Now, the way I do this is I look at the quadratic equation and I write down a is equal to this, b is equal to this, c is equal to this. And then I substitute those numbers into this formula and then do the arithmetic. If you need help doing the arithmetic underneath the square root symbol, get that calculator out. So solve using the quadratic formula. I would probably factor this because it is factorable, but we're going to practice the quadratic formula. So I have 2x squared plus 9x minus 5 is equal to 0. So now I'm going to determine what a, b, and c are. So we first look at the x squared term. The number in front of the x squared term is a. So a is equal to 2. Then we look at the next term, the x term. And we look at the number in front of the x. And I've got plus 9. So b is positive 9. And then I look at the constant. What is that number? The constant is -5. That is correct. The sign always goes with that number. So since there's a minus in front of it, C is going to be -5. Okay, so now let's write down the quadratic formula. X is equal to minus b plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. Now, when I substitute a number into the quadratic formula, I do it with parentheses around it. And there is a method to that madness, because when I substitute with parentheses around it, I mitigate some sign errors. So now let's do that substitution. So I have a minus, and I'm going to substitute in for b that number 9, plus or minus. Again, I'm going to substitute for b the number 9, minus 4 times a is 2, times c is minus 5. And that is where particularly we want to be careful with our substitution. We want to be sure we substitute the negative in for that variable. And then we're going to divide that whole shebang, the whole thing, by 2 times 2. A is the number 2. And then it's a matter of carefully doing the arithmetic. So I'm going to go to the next slide. Okay, so let's now do a little arithmetic, a little PEMDAS. Okay, so I could just remove the parentheses around the 9. The negative says that I'm going to change that positive 9 to a negative. So that's going to be -9 plus or minus underneath that square root symbol. I could take my handy dandy calculator out and just type this in exactly the way it's written. 9, use my squared button, subtract, and then do the 4 and use the parentheses to multiply those together. I could do that on my calculator. No problem whatsoever. Let's just go ahead and do this. 81. Now minus is going to give me a plus. When I multiply two negatives together, that becomes positive. And is that 40? Is 4 times 2, 8. 8 times 5 is 40. And we're going to divide that by 4. Now I'm going to complete the addition underneath the square root symbol. That's going to be -9 plus or minus the square root of 121 divided by 4. And you can take the square root of 121. So take your calculator out, find your square root symbol, put 121 in there. It is 11. So the square root of 121 is the number 11. So we're going to write x equals -9 plus or minus 11 divided by 4. Now we have to figure out what the two solutions are. And I knew this was factorable when I looked at it. I could just look at it and know it was factorable. And I know definitively that it was factorable because that square root, you can take the square root. So whatever's underneath that square root symbol, if it is a perfect square, you could have factored it. That's information you'll learn again in college algebra. So let's go over here. We have x is -9 plus or minus the 11 over 4. That's what our quadratic formula reduced to. So we have two solutions for x. X is -9 minus 11 over 4. And x is -9 plus 11 over 4. So we're going to take that -9 and subtract 11 from it. Then we're going to take that -9 and we're going to add 11 to it. Plus or minus. Plus 11 or minus 11. So what do we get? Is that -20 over 4? Is that -5? Is this 2 over 4? Is that 1/2? So what are our solutions? Boy, that's a great brace. Let's see if I can do that better. -5 and 1/2. And you can certainly take your calculator out and check your solutions. I highly recommend, time permitting, that you check every solution to every equation that you solve in your entire life. Solve using the quadratic formula. This is not factorable. And I'll know that when I substitute into the quadratic formula, I'm going to see that that square root, the thing under the square root called the radicand, FYI, is not a perfect square. So I'm not going to be able to take the square root of it. All right. To be able to use the quadratic formula, I must be in standard form. In standard form is where we have everything on the right-hand side and 0 on the right. So everything on the left-hand side and 0 on the right. Well, that is not the form that I'm in. So I'm going to subtract 4x from both sides. So over on the left, I now have a 2x squared and a minus 4x. On the right-hand side, 4x minus 4x is 0. So I'm left with 1. Now I need to, again, put this in standard form. So I need 0 on the right. So I'm going to subtract 1 from both sides. On the left, I end up with 2x squared minus 4x minus 1. On the right-hand side, 1 minus 1 is 0. So now we are in standard form and we can use the quadratic formula. So I need to determine what A is, what B is, and what is C. What's A? What's B? What'd you say? What's B? You have to put if you don't get this, yeah, exactly. That's why I don't like the quadratic formula. However, in this particular problem, there's no other way to solve it. This is it. Okay, then what's C? -1. So always make sure you take that sign that's in front of that number with it. The sign goes with it. All right, so now we're going to plug and chug into the quadratic formula. So x is negative b plus or minus the square root of b squared minus 4ac over 2a. And whoops, sorry about that. And a, you told me was 2. B, you told me was -4. And C, you told me was -1. And again, I'm going to plug those in with parentheses around them because it helps me mitigate the sign errors that I can make. And yes, I occasionally make a sign error. So we're going to take a minus sign in front of what B is. What is B? -4 plus or minus. We're going to take that -4 and we're going to square it. So again, that first number underneath the square root is always going to be positive because when you square -4, you're going to get positive 16. And then we're going to subtract from it 4 times what's A? 2 times C, which is what? -1. And we're going to divide the whole thing by 2 times 2. 2a. And then chug through the arithmetic. Okay, what happens when you have a minus and a minus minus? You get a plus. So the opposite of -4 is +4. So that is 4 plus or minus, what do we get underneath that square root? 16. Is it going to be plus? Yeah, minus minus is going to give you plus. Is that 8? 4 times 2 is 8 over 4. Okay, so this is going to be what? 4 plus or minus the square root of 24 divided by 4. And honest to goodness, are you all listening to me? You're all awake? Not everybody's awake. I got 2 sleepers in here. We should drop something. Worked. I will accept that as a solution. If you don't reduce the radical, I'm fine with that. My lab math is not going to be. I'm going to broke my fingernails the other day. And it wasn't your class, it was another class I was sitting there going. They were all looking at their computers. Anywho, my lab math is going to require that you simplify that radical. So let's remind ourselves, this is, gosh, so long ago, chapter P. Let's remind ourselves how to simplify a radical. So the square root of 24, I need to write that 24 as a factor of a perfect square and something else. So 24 has factors of 4 and 6. I mean, it's 12 and 2, but neither 2 nor 12 are perfect squares. So the only way we can write this as a product of a perfect square and some other number is to write it as 4 times 6. And then from the laws of radicals, that is the square root of 4 times the square root of 6. The square root of 4 is 2. So 24 is 2 square root 6. So we make that adjustment in our quadratic formula. So we now have x is 4 plus or minus 2 square root 6 over 4. This right here is equivalent to the square root of 24. And now I can factor a 2 to simplify this as much as possible. I'm going to factor a 2 from the numerator. So we get 2. If I divide 4 by 2, I get 2. If I divide 2 square root 6 by 2, I get the square root of 6. And then I can cancel that 2. So the solution is 2 plus or minus the square root of 6 over 2. And again, they're not going to listen to me. I am perfectly okay with that. So I will check your exam. If you get it that far, I'm going to give you credit. And why? Why would she do that? Why would she care? Okay, so I am old enough to remember when I didn't bring a calculator with me. I didn't have a calculator. I didn't get a calculator until I was a junior in high school. And I stole it from my father. He let me have it. Okay. So my dad he was a test technician at Tinker Air Force Base, and he tested jet engines. So they would bring them up in a test cell and make sure everything was what it's supposed to be. So he would have to make calculations. And so they would do it using slide rules. And he saw this calculator at Sears and Roebuck. They don't even exist anymore. He saw this calculator and he thought, I'm going to buy that calculator and use it out at work. So he buys this calculator. It was about this big, and it was an LED screen. So it's bright blue numbers. It took a 9-volt battery. The only place you use 9-volt batteries anymore is your smoke alarms. It took a 9-volt battery. It lasted about 10 minutes on that 9-volt battery. Big old blue letters, just zapped the power out of that 9-volt battery. So he bought an adapter, an AC adapter, so you could plug it in. And it had trig function. It was a scientific calculator. It had trig functions on it, and I was taking trig. So I borrowed it. And I would go into my trig class and I'd go find me a plug-in and sit by the plug-in, plug it in. But the point of that story is prior to that, and that is, my dad was always so innovative. For him to get a calculator in 1976 was a pretty big deal. But before that, to be able to find the square root of 24, I had to go use a table. So I had to go find a table that gave me a decimal approximation to the square root of 24. With calculators, what do? I put the square root in there, put the 24 in there, and I get a decimal approximation. And if you're really going to be using this number in a calculation in STEM, you're going to be finding decimal approximations to it. So I'm okay with you leaving it like this because I know the decimal approximation is going to be the same for that as it is for that. Same decimal approximation. All right. All right, so strategies for solving these things. I have ax squared plus bx plus c is equal to 0, and it can be factored easily. Then factor it. going back to this example over here. So much work, so much work. Look at all the work we did to solve that using the quadratic formula. This factors. The only way to factor 2x is 2x and x. And then we're going to put factors of -5 in here, 5 and 1, so that when we FOIL it, we get 9 for the middle. So that is correct. If I FOIL this, I get minus x, 10x, 10x minus x is 9x. So what is the solution? I set the 2x minus 1 equal to 0. I set the x plus 5 equal to 0 and solve the resulting equations. So 1/2 and -5. And then how much faster is that than all of that? So if you can factor it, I highly recommend, and I highly recommend you've done your factoring homework. I haven't checked. I should have checked before I came in here today. If you haven't done your factoring homework, you need to do your factoring homework. So for example, the 3x squared plus 5x minus 2 is easily factorable. That's going to factor to 3x minus 1 times x plus 2, set each factor equal to 0, and solve the resulting linear equations. If you have a quadratic where there is no x term, do you see that? There's no x term there. You've got ax squared plus c is equal to 0. Then the easiest way to do that is the square root property. So you move the constant over to the right, divide both sides by the constant in front of the x squared, and then take the square root of both sides. Just remember, when you do that, you have to put that plus or minus in front of it. So we have 4x squared minus 7 is equal to 0. There is no x term. So move the 7 to the right by adding it, divide by 4, and then take the square root. So x is plus or minus the square root of 7 over 4. And you do have a law of radicals, that is the square root of a over the square root of b. So it's the square root of 7 over 2. If you have u squared is equal to d, where u is some algebraic expression squared, you can use the same thing as you did on the previous slide. Take the square root of both sides. Just be sure that you put a plus or minus in front of it. And then if all else fails, you can't figure it out, the quadratic formula always works. Always, always. It works for every quadratic equation in existence. Just be sure. And in this particular quadratic, what's a? What's in front of that x squared? A 1? And b is -2? And c is -6? So just be sure you make sure the sign is correct before you start plugging it in. And you can see the simplification they did. And if you want me to check your homework, you want to, I said, I got the wrong answer. Can you check this? If you'll tell me what you got originally before you tried to simplify it, I can check. Okay, so how would you solve that? Based on the 2 slides prior to this one, what would be the easiest way to solve it? If there's no x term, no x term, no x term, get rid of the 3. 3 is being multiplied times the x squared, so we are going to divide. What's 144 divided by 3? What'd you get?
No, I don't even know.
Don't even know? It could be something. I don't know what it is. Like, What'd you get? It should be 48. That's what it
Yeah,
should be.
that's, there we go.
So then we're going to take the square root of both sides. Be sure you put the plus or minus. And I am perfectly okay with you leaving it like that. Now, my lab math is going to want you to simplify the radical. So you're going to look at 48. Can you think of a perfect square factor that's a factor of 48? Maybe not right off the top of your head. This is why I say it's important you know what your first 15 or so perfect squares are. 2 squared is 4. 3 squared is 9. 4 squared is 16. Ding, 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 ding. This is 16 times 3. So this is plus or minus the square root of 16 times 3. Laws of radicals say that that is the square root of 16 times the square root of 3. I didn't make that up. That's a law. So that's plus or minus the square root of 16 is 4. 4 square root of 3. Five squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 100 squared, 10 squared is 100. Getting ahead of myself. 11 squared is 121. 12 squared is 144. 13 squared is 169. And then I'm kind of done after that. 14 squared, I think that's 196. You might check me. And 15 squared is 225. And then I'm done. I don't know what 16 squared is. And I don't really care. I mean, once you get up that high, you're probably not going to have that as a factor in your radicand. All right. What about this one? Well, there's nothing I can do with this until I get this 2 over here. So I'm going to subtract 2 from both sides. And that is not factorable. There are not going to be any 2 factors of -2 that I add together and get 2. That is not going to happen. So what are the factors of -2? -2 and 1 or 2 and -1? Neither one of those are going to add to the number 2. So this is not factorable. If it's not factorable, then what's your choice? The quadratic formula. So that's what we're going to use. And you do not have to memorize the quadratic formula. It is on your formula sheet. But you do need to figure out what A, B, and C are so you can plug it in. So what's A? 1. Very good. What's B? What's that right in front of it? It's +2. And what's C? It is -2. And they go in order. If it's written in descending order, the A, B, and C go in order. The first number in front of the first term is A, the second one is B, the third one is C. C is always the constant. C, constant, C, constant. Okay, now we're going to plug it in. X equals -B plus or minus the square root. Underneath that square root, we have B squared minus 4 times A times C. And we're going to divide the whole thing by 2A. So let's make those substitutions. We get -2 plus or minus the square root of 2 squared minus 4 times 1 times -2. The whole thing over 2 times 1. So it's -2 plus or minus the square root. 2 squared is 4. Minus gives me plus 8 over 2. X is -2 plus or minus the square root of 12. divided by 2. I am perfectly okay with that answer. Now, the next teacher you have for college algebra may not be. Just warning you. But we would normally simplify the square root of 12. The square root of 12, FYI, memorize it, it's 2 square root 3. It's the square root of 4 times 3. It's the square root of 4 times the square root of 3. It is 2 square root 3. So x is equal to -2 plus or minus 2 square root 3, the whole shebang over 2. And you can divide everything by 2. Since you have 2 in both terms in the numerator, you can factor it out. So we get 2 times -1 plus or minus the square root of 3, the whole shebang over 2, and you can cancel the 2's. So the solution is -1 plus or minus the square root of 3. So why did I use the quadratic formula? Because the trinomial that I got on the left-hand side of this quadratic equation was not factorable. How about this one? I have 7x minus 1, the quantity squared is equal to 1. Will I have something in the form u squared is equal to d? So I am going to take the square root of both sides. So I'm going to take the square root of the left-hand side, which just gives me 7x minus 1. And I'm going to take the square root of the right-hand side, but I have to put a plus or minus in front of it. What's the square root of 1? 1. So you get plus or minus 1. So you get 7x minus 1 is 1, or you get 7x minus 1 is -1. It's one or the other. Solve the 2 equations. Is that 2? Is that 2/7? And then what's the other one? 0? Now, there's a real temptation for students to want to go ahead and multiply that all out and then use the quadratic formula, and that's fine. That's fine. It's just probably more work than you need to go through. If you have an expression squared on the left-hand side of the equation, just take the square root of both sides. But be sure on the right-hand side, put that in your brain somewhere. On the right-hand side, you got to put a plus or minus. Gotcha. And by the time, if you have ever, well, you're not going to have me for college algebra. I'm going to be laying on a beach somewhere. next fall, I'm going to be laying on a beach somewhere. But if there's a temptation not to leave that minus off, remember, your next college algebra teacher is going to be really mean about it because I don't give credit for it. If you leave the minus off, I just wrong. Because by the time you get to college algebra, that should be a no-brainer. And then last but not least, something like this, x squared plus, and I took all of these problems from your homework. All of these problems directly came from the 4.4 homework, all of them. So you're going to have something similar in your problems. Now, in this case, and we discussed this when we talked about factoring in section 4.2, if you have two terms and neither one of them is a constant, they both contain an x, then the only way to factor that is to factor out a common factor. And that's the best way to solve this. And as you recall, if you have the case where you have a binomial on the left-hand side and 0 on the right, one of your x's is going to be the number 0. That is true. So if you have no constant, factor a common factor. Okay, there is no common constant factor. So there's no constant, but I do have an x squared and an x, so my GCF is going to be x. You can always factor out the variable with the smallest exponent. So we're going to factor that out. So I'm going to take the x squared and divide it by x. I'm going to take the 8x, I'm going to divide it by x. So it factors to x times x plus 8. Is that correct? If I distribute, x times x is x squared, x times 8 is 8x. And then we just set each one of those equal to 0. Using the zero product principle. So the solutions to this quadratic equation, which I should be writing these as sets, and this is how you're going to put these into MyLabMath. They give you the braces and then they give you a field. And in that field, you're going to type 0 with a comma, and then you're going to type in the -8. And we are done. Semester's almost over. You've got 2 weeks left. So you're going to go enjoy your Thanksgiving week. Monday, December the 1st, we're going to review for this exam. Then you'll have the opportunity Monday through Thursday to go to the testing center and take it. On Wednesday, December the 3rd at 11 a.m., I will review for the final. I will take the final review and do every single question. I did it yesterday and only had to write down 2 questions. It's that straightforward, in my opinion. Are there any questions? Go have a wonderful Thanksgiving, and I'll see you on the 1st.